Cool. All right. Hi, class. Welcome to our snow day lecture. I am going to do the best I can to write things clearly so it's easy to work with. Let me see if I can make this full screened. Um, I'm not going to have my camera up because you're just going to see the top of my head as I'm writing on a little tablet. So sorry about that, but we're in module 3, which is on functions. So we're going to start with some definitions. So a set of ordered pairs x comma y is called a relation. Let me mute my phone, sorry. Okay, so a relation is going to just be kind of a normal, it's a relationship between x and y, and we can often represent it as a set of points. So can be represented set of points. So that might look like 3 comma 2, 4 comma -1, maybe 0, 0. Just some collection of points. We use these little squiggly braces to denote this is a set or a collection of points. It could also be given to us as a table. So we'll have x and y, and we'll have some values. So maybe 3, 2, 4, -1, and 0, 0, just giving us the same points, but given as a table. It could be a graph. So we have our x and y axes, and then we'd have maybe some just general points on here. So here, 0, 0. We go over a couple and up some. There we go. We go over and down some. I'm not labeling the points, but they're approximately these three again. It could also be given as an equation. So maybe we'd have y equals 5x plus 2. So we usually have y on one side and then like a little bit more interesting things happening with the x variable. We could also have more, but these four are our most common. So set of points, table, graph, and an equation. All right. Scroll down. So the set of x values in the ordered pair is called the domain, which is the set of all inputs. All right. The set of y values in the ordered pair is called, sorry, the tablet I'm using is a little strange. The range. All right, so this is the set of all outputs. Okay. So we call this section functions because functions are our main focus, but functions are a special type of relation. So a function is a special relation where every input has only one output. So that's important. And so what this means is, let's say I have the X value 3, and I'm going to send that to 5. I can't then have 3 again and send it to 0. See here, now our 3 is getting sent to 5 and 0. So we have one input of a 3 going to more than one output. So this is bad. But if instead we had something like this, maybe I have an input of, I'm going to use letters because it can be anything. Maybe I have an input of A, and I'm going to send A to the number 1. And then I'm going to send B to the number 1. And then I'll send C to the number 1. So just because a bunch of things are hitting the same output, that's fine. Because if we kind of have A, B, and C, we kind of imagine all of them get sent to the number 1, but we can see only one arrow leaves from every one of these inputs. Versus up here, we have 3, we have 2 arrows leaving 3. So that's when it's bad. This one over here, we can send things to the same guy. That's fine because each input still has one output. Okay. So when we want to determine if something is a function or not, we're going to mostly be looking for repeated outputs, or sorry, inputs. So, so we want to look for repeated inputs. So for example, let's say I have a table with a domain, which is again our set of inputs, and a range. So my domain is going to be N, F, K, C, and Z. And the corresponding outputs are going to be R, N, R, R, and R. All right. So this is a similar example as what we did before, but so a lot of our inputs are getting sent to R, but if we look here in our domain, every single one of these letters only appears once. So that's good for us. So that means that this guy is a function. Okay. Versus if we have a table, like our next example. So I'm going to use big D for domain and big R for range, just for simplicity. So here I have a domain of -6, -4, 8, 0, and 8. With corresponding outputs 1, 5, 2, 5, and 1. So when I'm looking at these, I want to look at my inputs, so my domain. So I have a -6, a -4, I have an 8, a 0, and then I have 8 again. So the 8 appears twice. Oops, it's a W. Twice as an input. So we see 8 is getting sent to 2 and 1. So 2 different outputs. This is bad. This is not a function. Okay. That is the main idea for all of these. So sometimes we will be given tables like this. Other times we will draw kind of just arrows to kind of make everything clear. So my domain on one side, I'm going to have the letters F, R, D, and W. And then in my range, I'm going to have 3, 5, -1, 0, and -4. So F is going to get sent down to 0. R is going to get sent to 5. D is going to be sent to 3. And W is going to be sent to -1 and -4. All right. So in the same idea, we want to see if our inputs are getting sent more than one places. And looking here at W, we have 2 arrows leaving W. So that's bad. Everyone else just has 1 arrow. But the moment you have one thing that breaks being a function, you're not a function. Okay. So if we were to have just erased this here, let me get back that blue arrow going to -1. And instead we had this new thing is a function. Because now everything has 1 arrow. All right. So I hope you can see that distinction. All right. The other thing when we're looking at for these is the list of points. This is an example still. So if I have a list of points, 1, 2, 3, 2, 5, 1, and 6, 1. This is my list. I have 4 points, so I have 4 ordered pairs. So same thing's going to happen. I'm going to look at the set of inputs. So my input for this one is a 1, a 3, a 5, and a 6. So since none of my inputs repeat, everything will have a unique output. So this one is a function. And this is because we have no repeated inputs. Let's get that E looking a little bit more like an E. All right. So versus if we have something where we have the collection of, oh, sorry, that bad. All right, the collection of points 2, 3, -4, 2, -1, -3, and 2, 4. Okay. So now, if we look at all of our inputs, notice here we have a 2 and a 2. And 1, 2 gets sent to 3, and then this one gets sent to 4. So again, we have one input getting sent to more than one point. So this one is not a function. The input 2 is repeated. Oops, I'm spelling repeated wrong. Okay. So that's like when we are given a bunch of just kind of raw data. It doesn't, we don't have anything very intuitive here. It's just brute force check. So the one type of function, or one of the types of functions we haven't looked at yet, is when we have a graph. And there's going to be a very special way for us to check if we have a function when we have a graph. We're going to get to use something called the vertical line test. Okay, remember that x equals a is the equation of a vertical line through a. A just kind of placeholder for a number right now. So when we're given a graph, if we can like check all of the vertical lines going through it, and it intersects only one time, we're going to be good. So I'm going to abbreviate vertical line test as VLT. So what this says is a graph defines y as a function of x if no vertical line intersects. So think about like the vertical line is touching our graph, so intersects the graph in more than one point. Okay. So this is the big way to check if we have a function with a graph. You just use the vertical line test. So let's kind of draw some graphs and think about it. They're going to be kind of loose pictures here because my tablet is only so good. So if I have maybe just some points, come on, work with me. There we go. All right. So here I have 4 points. And if I imagine drawing vertical lines going through every single one of them, no other point is getting hit. So that's what we mean by you're just going to check the vertical lines. Anywhere else that there's just kind of blank space, we're hitting the graph no times. 0 times is still less than 1, so we're good. Or less than 2. Yeah, see, this is an example. Forgot to do that. So this function here with just a collection of points graphed is a function. Okay. Versus if I have a collection of points, come on, draw. There we go. So something like this, and then I tried to draw it as clear as possible. This vertical line right here is intersecting 3 points. So it's definitely more than 1 point. So this one here is not a function. I'm just going to write not for this one. And it does not pass the vertical line test. Okay. So I'm going to draw a couple of graphs now. One, two. Sorry, my tablet is like a little dinky thing back from COVID days. Has no screen, has no nothing. It just USB connects to my laptop. So I can't, like if I draw on it, I can't watch the screen at the same time. So it's a little rough. So sorry that some of my lines are squiggly. So say I have a graph that looks like this. One that looks like this. One like this. And then just a line like this. So kind of looking through here, we can see if we draw a vertical line here, we're not going to pass the vertical line test because we have a point here and here. So I'm just going to do X's for bad. All right, so that one's not a function. Here, I'm going to kind of draw a couple of vertical lines. If we're checking in a couple of places, every single point, and kind of imagine, I like to kind of take my hand or a pencil and run it along the graph, and if it only hits 1 point everywhere, we're good. So this one, I'm going to put check mark, is a function. We can see everywhere we're hitting multiple points. Here with this circle, imagine it was connected there. It doesn't matter, because if I go here, I hit more than 1 point. So that one's not going to be a function. And then over here with the line, we can kind of see every single place we check a vertical line on the graph. It's only going to hit this line once. So this one, yes, is a function. All right, then there's something special about graphs that I want to talk about. So let me draw a picture to kind of show us. I'm going to try to be a little clearer with. Oh, that was bad enough. Let's try that one again. That's a little better. Okay. So sometimes we're going to have graphs that have filled in circles, and then we're going to have open circles. So a filled in circle means that this point is filled in, this point is included. That's supposed to be a D, included. All right. An open circle. So it's open because there's like white in between. So it's open or hollow. An open point is not included. So what that means is we're going to get very, very close to these open points, but we don't actually hit this open circle. We get super close, but then we jump away and we don't actually get there. So the 2 points where we would maybe be in trouble with a vertical line are where we have these two kind of dots on top of each other. But because one of them is filled in and one of them is kind of removed in both cases, we only actually get this one value with the filled in circle. So this one is a function because at the two kind of trouble points, because everything else is just a little line, so any other vertical lines are fine. But here, these kind of tricky spots, since we removed the other bad point, we preserved being a function. If one of them had been filled in, then we would have had 2 points and it would not have been a function. So this one's okay versus, come on, scroll, there we go. If I have a function like this, so notice here, at just this one point here, we're okay. This point's open, this point's closed. But if I move over just a little bit here, I hit this point and I hit this point. So that's going to be bad. So 2 points on the same vertical line. So not a function. So be careful. Sometimes they'll put an open circle kind of near, but it'll still will overlap a little bit. So double check when things like this happen that you don't get tricked by one of these. Okay. So the last type of way that we talk about functions in this class is with equations. So checking if an equation is giving you a function is a little bit harder. So let's look at some things that can go wrong. Sorry, my S's are getting a little sad. There we go. So let's say I had y equals x plus 3. And I want to plug in x equals 63. So then I will have y equals 63 plus 3 equals 66. So that's fine. So this, oh, I'm supposed to plug in 61 for the rest of them, but that's okay. For this one, it's fine. So this guy is fine. And notice we have a single y, and then we have some stuff with our x. So that's going to be a theme here. Having things with our x will be fine. Having things with our y, that's where we're going to be falling into some trouble. So if for my next example, if let's say I have y squared equals x plus 3, and I'm going to plug in 61 this time, so sorry about that. Plug in x equals 61. So then I have y squared equals 61 plus 3 equals 64. Okay, so I have y squared equals 64. To find the solution for y, I'll take the square root, but when I do that, I have to remember I have a plus or minus the square root of 64, which means my answer is plus and minus 8. So what that tells me is my input of x, oops, sorry, being 61 as a point, I'll have 61 comma 8 as an answer, and 61 comma negative 8. So for one input, I have two outputs. So this one's not a function. Okay, so we did something to our y here. We have a y squared. Similarly, if I have the absolute value of y equals x plus 3, and I plug in x equals 61, I get the absolute value of y equals 61 plus 3 is 64. That means y is plus and minus 64, because that's what it means with the absolute values. So again, I have the point 61 comma 64, and it's supposed to be a little and symbol. It's kind of crappy. There we go. 61 comma negative 64. So this one's also not a function. I'm just going to put not for now. All right. So again, we did something to our y that was bad, and that let us, that kind of showed us that this is not going to be a function for us. And then the last example, if we look at, if I have y cubed equals x plus 3, and I plug in x equals 61, I get y cubed equals 64, which gives me y equals the cubed root of 64. We don't have a plus or minus when we do the cubed root. And then let's figure out what our answer will be. So we have 64 raised to the cubed root. And our answer here is going to give us 4. Okay, so this one is a function because we're good. Our 1 point is just going to get one output. So showing you something is a function is a little harder. We're obviously not going to be able to plug everything in, but we're going to have some tricks to identify that it's you can always show something is not a function by just finding a point that will break, like the two examples we did before. So the general rule, absolute value of y squared, y to the 4th, y to the 6th, kind of keep going forever, y to an even power, it should be a v, there we go. These ones are all going to have not a function. Oops. Oh, there we go. All right. So it's the absolute value and then even powers of y. So when you're doing something to y, just double check. And then anything done to x is fine. Pretty much. It's very hard for an equation to have things done to x where we're not going to be okay. So for example, y equals the square root of x is good. Y equals x to the 7th minus the absolute value of x plus the square root of x minus 1 over the square root of x Like you can kind of see anything we do to x, we're going to be okay. And then y to odd powers is also okay. Because previously with the square root and, sorry, no, with the squared and the absolute value and other even powers of y, the annoying thing is when you plug a negative number in, it gives you the same value as though you'd plugged in an odd number. But here, let's like just see an example. Negative 2 cubed is negative 2, sorry, is negative 8. And 2 cubed is 8. So those are two different numbers versus negative 2 squared is 4 and 2 squared is 4. So that's the kind of issue. When you have a negative number and a positive number, they're both getting sent to the same thing. So when we're doing things with the y, which is our output, and we kind of have to work backwards to figure out our inputs, that undoing with the plus or minus is the thing that's really going to be difficult and hard for us to solve for. So that's what you want to look out for. There are, in the notes on Blackboard, there's about 10 examples of problems. It just takes forever to write out. We've kind of gone over them if you want to look. And there's a lot of questions on ALEKS about identifying when equations are and are not functions. But the real trick is look at the y, and if a squared or an absolute value has happened to the y, specifically the y, it's probably not a function. Find a bad point. Anything else we're doing is gonna be fine. Something I do want to say, one other kind of weird one, just to kind of end us with. Let's say I have x equals 7 over y, kind of an example. And you're looking at this and you're like, something's been done to my y, but you can do a little bit of algebra. So let's multiply both sides by y. So I have x times y equals 7 over y times y. So then my y's on this side will cancel, and I will have, sorry, my mouse doesn't want to scroll. There we go. X times y equals 7. And now I'm going to divide both sides by x. And I have y equals 7 over x. So I do end up with a y alone equaling something done to an x. And remember, we can do anything we want to an x, but our y is alone. So sometimes if you want to simplify, solve for y and see what happens over here. And that's if we solve for y with those previous ones when it was a y squared or an absolute value, you have to break it into the cases. If it's a y alone, you just do a little algebra and it's going to work out for you. Okay, that's where we're going to end. Sorry this is getting to y'all so late. I was at a conference all day from 8 a.m. until literally coming home to do this for y'all. So I'll upload this and then tonight and then hopefully try to watch this tomorrow at some point or just sometime before class. We're going to talk about function notation on Friday, and we also are going to have Wiki 3 on Friday. So try to bring a laptop. I will email y'all as well to let you know that there's a video out and about the wiki. Remember, exam 1 is still happening this week as well. I'm gonna send a whole big email, but I know a lot of us are not email prone. We'd rather hear it. So this is as close as we're gonna get to in class until I see you guys on Friday. All right, I will see y'all then. How do I stop recording? Did it not record? Oh no, we're good.